Jai Hind everyone. I am Anupam Kumar Saini, Assistant Professor, AKGEC, Ghaziabad. Today I am going to discuss about the regular expression, that is the topic of Theory of Automata of subject second year student for CS and allied branches of CS. So what is regular expression? When we represent any string in the form of expression, means with, using various operators, union, concatenation, closure operator, and we represent the language in regular expression form. So that is the regular expression. Then the language accepted by the finite automata can be easily described by simple expression called regular expression. It is the most effective way of represent any language, that is syntactical expression. So basically what is regular expression? Means if there is a input symbol sigma equal to a, b, these are the two input symbol, and if we generate a string start with a, we write that say that the string start with a, then the language will be a start with a, then ab, then aa, and so on. And we want to write this language in the form of regular expression, means some compact form. So we write this language in compact form using the symbol union, closure, and concatenation. So for this language we write it in the form of regular expression. Is the regular expression will be a start with a, means regular expression will be start with a, and after this any symbol can occur, means a will be b occur, a or b, means start with a, after it a and b are any combination of a and b. So we write it here a plus b star, means string start with a and after that any string will occur. So this is the form of regular expression, means language representation in compact form with the use of union, concatenation, and closure operators. So the language accepted by some regular expression are referred to as regular language. As I know, the string accepted by regular language is known as regular expression. A regular expression can also be described as a sequence of patterns that defines a string. For example, 0 1 star plus 1 0 star. Here we see that the string start with 0 or 1. So regular expression are used to match character combination in string searching algorithm used this pattern to find the operation on a string, various operation on strings. So some main core operators used in regular expression are regular expression x star, means closure operator. It means 0 or more occurrence of x, means it means if right here x star, this is the representation of loop in the DFA in finite automata, and the string start with epsilon, means if right here the string will be is occurrence of x will be 0, 1, 2 and so on. Means if the occurrence of x is 0, then output is the language will be the epsilon. If occurrence of x is 1, then output will be the single x, and occurrence of x is 2, then xx will be the output, means language will be xx, and we write it in the form of regular expression, it will be the x star. In the regular expression, x plus means one or more occurrence of x. It is also known as the positive closure. Occurrence of x, it can generate x, double x, triple x and 4 times x and so on. X means it will not accept epsilon, means if we write here positive closure equal to x asterisk minus epsilon. So this positive closure equal to, when we remove the epsilon, means in this closure, clean closure, then it will be the positive closure. So next operator is union. If L and M are two regular languages, then their union L union M is also a union. So L union M, if the string is S and S is in language L or S is in language M. And intersection, if L and M are two regular languages, then their intersection is also the intersection. It means L intersection M equal to ST. S, that is from S belongs to language L and T belongs to language M. So this is the clean closure operator. A clean closure operator given in language L. If the occurrence of language L is 0, then output will be epsilon. If occurrence of language 1 is 1, then output will be the string of the length that is given. And if the occurrence of language is 2, then it will be the length of 2 string. For explain here with example, if L is a language given 1 0 0, if we consider as L0, it means occurrence of the language is 0, means epsilon will accept. If the occurrence of L language is 1, then this string will accept 1 0 0. If the occurrence of L is 2, means L1 L2, then output will be the 1 1 1 0 0 and 1 0 0 1 and 4 times this 0, means combination of these two elements, concatenation of L. Similarly, language L, when L cube and L to the power 4, 5 and so on, means it write it here L asterisk, any combination of the language. So this is the example of one DFA. Write it here for AB. So regular expression for this is the A dot B, means for this diagram accept the string A B, and we write some finite automata with explain with the help of language and regular expression. Suppose we consider Q0 is the initial state and that is also the final state, and we accept the string A. It means the string accepted by this machine, the means language will be A. First it is in the initial state, so string will accept with epsilon without any occurrence of A, means occurrence of A is 0, then epsilon will accept A. If occurrence of A is 1, then A, then A, double A and so on. So the language of this finite automata is epsilon a this way, and the regular expression of this, we write regular expression a star. Okay, if the finite automata is q naught, we consider as a, start with a, and the final state we write here some symbol a we use. We can write it, for this we write here language will generate for this is the a, if at least to single a will accept, and this a consider as a loop, and it will be the occurrence of the a. If occurrence of a is 0, then this one accept. If occurrence of a, then the string a will accept, and so on. So this is the language for this finite automata, and the regular expression we write it here for this will be a, at least a will accept, then we write a star. A star means at least a will accept. We can also write it as a plus, means string start with a, so we can write it here as a plus. So other example for DFA for a or b, except a or b, then we see the diagram. Initial state q naught, input symbol a or b, now final state q1, it means a or b, q1 also write it. So we show in a DFA in this form a or b, it is only the for the description. We write it here for this DFA a plus b, except a or b. So these are the some example to find out the regular expression of these. First one is the write the regular expression for the language accepting all combination of a's over the set sigma equal to a. It means here we accept the string with all combination of a's. So all combination of a means the occurrence of a for the regular expression. So what will be the language for this? L equal to, if occurrence of a is 1, then output will be a. If occurrence of a is 2, then this will. If occurrence of a is 0, then what will be the output? It will be epsilon. Means language accept epsilon, and so on. So regular expression for this is regular expression is a star. Okay, means the regular expression for the language accepting the combination of a's. Combination of a is the occurrence of a. If occurrence of a is 0, then the epsilon will accept. Occurrence of a is 1, then a will accept, and occurrence of a is 2, then a will accept using this regular expression. So next question, write the regular expression for the language accepting all combination of a's except the null string over the set a. Here say that the all occurrence of a except null string means we subtract epsilon from this language. So language will accept here a, and so on. So for this question number 2, the regular expression will be A plus, means positive closure, means accept the string at least single A. Epsilon will not accept here, as written here, except the null string. So example number 3, write the regular expression for the language accepting all the string containing any number of A's and B's. Means for this the language will be AB, any number of A's and any number of B's. So A, B, B, any language combination of A with the symbol, input symbol A and B, any combination of A. Then the regular expression we write here for this will be any combination of A. It means A plus B whole star, means any combination of A will occur in this expression, in this machine. So if occurrence of A is 0, then epsilon will accept. Occurrence of A is 1, then single A will accept. Occurrence of AB is 2, then AB will accept. If the occurrence is 2, then string will accept AA, BB, AB and BA, and so on. If occurrence is changed, then the value will change accordingly. So next example, write the regular expression for the language accepting all the string which are starting with 1 and ending with 0 over sigma equal to 0, 1, means input alphabet is 0 and 1. So start with 1 and end with 0, means the language generated by this this statement will be start with 1 and end with 0. Start with 1 and end with 0. At minimum length of the string will be 1 and 0. And in between 1 and 0, any combination of 0 and 1 may occur. So if we construct the DFA for this, we draw the diagram, transition diagram. Q naught except with start with 1, then to key 1 and end with 0. And end with 0, and in between any combination of A or B occurs. So we can write it here A comma B, or we can construct it start with 1 or end with, if we consider it Q2, this is final state, and end with 0, end with 0. So similarly this will minimize as A comma B. Sorry, here we use 0 and 1, so it will be 0 comma 1. By mistake I write it AB. It will be 1 or 0. So for this we design a finite automata that will start with 1 and end with 0. Start with 1 and end with 0. This is the minimized finite automata, and write the regular expression for this will be our regular expression equal to 1 and end with 0. In between 0 or 1 may occur in 0 plus 1 star, any combination of zeros and ones. So regular expression for this will be 1, 0 plus 1 star 0. Start with 1 and end with 0, and in between any combination of 0 and 1 may occur. Next example, write the regular expression for the language L over sigma equal to 0, 1 such that all the strings do not contain the substring 0, 1. This is other example in which it says that the string that do not contain 0, 1 means 0, 1 cannot occur in string, means when there is a string 0, 1 that will not accept. So string do not contain 0, 1. So what string will accept? Means 1 and 0 will accept. 1, 0. 0, 1 not accept. So 1, 1 will accept. 0, 0 can accept. But combination of 0, 1 will not accept only. So we write the regular expression for it will be 1 star 0 star, means any combination of 1 and 0. So this is the answer of the question already discussed. First question, accept the string, that is regular expression A stick, and the second one, that is r equal to a plus, positive closure. This will accept the string, all the combinations of a's and b's. If the string occurrence of string A language is 0, then epsilon will accept. Occurrence of string will 1, then A and B will accept. If occurrence of language is 2, then AA, BB, AB, BA will accept. If occurrence of the language is 3, then these languages will accept, and we write the regular expression in the form of A plus B star. And this one, the first symbol will be 1, first symbol should be 1, and the last symbol should be 0. So write the regular expression, the language accepting the starting which are starting with 1 and ending with 0. Starting with 1, either regular expression 1, then end with 0, start with 1, and in between any combination of 0 and 1 may occur. And next the question is that do not contain 0, 1. So answer is the 1 star 0 star. So DFA2 regular expression. So DFA2 regular expression informally trace all the distinct path traversing cycle only once from the start state to each of the final state and enumerate all the expression along the way. So here the example are given, the DFA is given, and we have to write the regular expression for this. So what will the regular expression for this? First, this is the loop and this is represented with the closure with symbol asterisk. So we write it here a asterisk, then 0, then 0 asterisk, then 1, then 0 or 0 plus 1 ka whole star. So this is 1 star, 0, 0 star, 1 and 0 plus 1 whole star. So write it in the form of regular expression is 1 star, 0, 0 star, 1, 0 plus 1 star. So this is the DFA to regular expression construction. Okay, for the today, thank you. We will discuss in next class further. Thank you.